In the second stage of day 3's tutorial, having looked in the first part at more sort of sophisticated ways of generating meshes, we're going to build on that and now create an actual real model of Solent and water of the Solent using real bathymetry and a much more complex coastline. To do this, you'll need to download the day 3 zip. This I've already done it. Again, remember to just extract it. You'll have a forcing folder with the tidal forcing. We've now got a GIS folder, so Blue Canoe is actually capable of loading in shape files. And again, this ties in quite nicely, I guess, with your GIS course. But we've got 3 shape files here. Smooth Isle of Wight, the complex coastline, and we've actually got some bathymetric data here. And then we'll be using 5 mesh files as well that we've created to do various things to the grid. So let's open Blue Canoe. And the first thing we're going to do is import those shape files and just have a look at them. So rather than using file open, we use the file import, and you can see here there's a setting called shape files. And what we're going to do is just make sure you go to day 3, your GIS folder, and let's select all 3. We'll load them all in at the same time. Click OK for the first one, OK for the second one. The bathymetric data is quite a big file, so it will take a bit longer to load in. And what we're going to do is drag each of these, once they've opened, drag each of them to a new 2D view. Okay. So let's start with the coastline. So this is you can see a much more detailed coastline now with islands, and you can see the Itchen and the Hamble there on the test, Lymington. Let's bring in the Isle of Wight. This is a sort of smooth Isle of Wight, but again with a reasonable level of detail. And let's bring in the Bathy data as well. Now what you see straight away is that the Bathy data has these weird, it's shaped from left to right stripes. And the reason why that is if you just click on it, if you go to data, you can see we're actually in the X dimension. So it's plotting this by, and what we want it to be is the Z. So click on Z, apply, and what you can see now, as you'd expect, it's depth. Now we've done a lot of hard work for you and merged lots of different data sets together. There's probably about 10 different data sets together. You can see we're a bit short of data in Poole Harbour, a bit short of data in certain areas in the Solent as well. But we have good coverage of most of the Solent, most of Southampton Water, and around most of the Isle of Wight. We're missing data here in in Chichester Harbour. And the other thing you have to be aware of all of this data is to ordnance data muling. Most of the individual sort of data sets come to chart data, which is known as type. We've converted that to ordnance data muling, which is mean sea level. Your model needs to be relative to mean sea level. You have to be very careful doing that, because often people will combine 2 charts and forget to do that, and you'll get a stepped change. Okay, now with this land boundary here, it's just at the moment too complex. And that's going to be a problem when we build our mesh. So I'm just going to switch off the Bathy here and just remove it. But this boundary here is just going to be too complex, particularly up in the east. So we want to simplify that. And again, we've done the hard work for you. We've created a simplified version. So if you just open day 3 mesh, show all the files, there's this outline F convex. And what we can do is just drag that to the 2D view, and it's red. And what we've done is we've created this line to only cover the areas where we have bathymetric data. So we haven't gone into the rivers, we've missed out Chichester Harbour. Because our area of focus is here, that doesn't matter, but obviously we'd need to get data from there if we were going to build a more realistic model. Okay. And so what I'm going to do is just going to switch off this high res, and we're going to focus on this now. We need to load in a Poole Harbour. There's lots and lots of little islands in the Solent. but actually the only one big enough that's really worthwhile including is Pool Harbour, which is there. Okay. And what you can see if you zoom out as well, that we've done the hard work for you and created a approximate boundary file. So this is going to be our domain. Now, one of the things we're going to do is we're going to use a couple of other files as well. We want the resolution to be quite high resolution where we've got good bathymetric data. Actually, I'll just bring that bathy data back in. And you can see we've got high-res data along most of the coastline between this point here and that point. So we're going to want that to be a higher grid, smaller grid cells. So we've created this buffer 250. And essentially what that is it's the coastline. What I'm going to do is just double-click on it, tick the monochrome and make it green or something, just so you can see it a bit more clearly. And this is it goes 250 meters from the coastline, and then it goes sort of around. So in that area there, we're going to use that in the density of our mesh generator to create a higher resolution. So what we can do now is create a new mesh generator file, new mesh generator. And what we're going to do is call this Slumps and Water Real, SW Real, and let's call this one number 1. We're going to set the default edge to 1000. Click OK. Now what we want is we want the outline convex X in the outline. We want the buffer 250 in the density. In terms of the hard lines, we want Pool Harbour, and we want the smoothed Isle of Wight up here. Now these Isle of Wight, it's quite high resolution, so what we're going to do is resample those before we use them. So let's click on each in turn. I'll start with Pool Harbour, right click, go resample. Now these have an average length of 140 meters, but I'm actually going to just reduce that slightly. Let's change that to 250 meters. Again, add that to the name, just so you can keep track of it. Click OK. And what I'm going to do is I'm going to resample the smoothed Isle of Wight as well. Equal distance, 250 meters. Now I'm going to drag, we want it in the top directory, so drag the smooth into the top of hard lines and the resampled Pool Harbour. And what we can do is remove these, right click and go remove. So what we've got there is we've got whoops, I've done the wrong one, so I'll have to do that again. Resample the Isle of Wight, equal distance, 250 meters. Drag that to hard lines. Keep on dragging the wrong thing. Remove. Remove. So we've got our outline, our buffer, and then our hard lines in there. And what we can do is now run this. And this will take a bit longer now, just because we've got much higher resolution. So it's almost finished. Just wait for it to say done. Done. Okay, now we can press OK. And there's our new mesh. Now let's just rename this straight away. Double click on it or right click on it. Go to metadata. Let's call this Southampton Water Real Mesh 1. Okay. And what we can do is drag that into the 2D view. And here's our mesh. What you can see is we've got very high resolution in that buffer zone, high resolution around the Isle of Wight. If you can double click on it, go data, you can see our number of nodes. Now this is a good first attempt, but it's a bit too high resolution and there's not enough of a nice sort of smooth, but we'll use this as a basis. So let's just go in. So you can see it's looking good. It's a nice mesh. I'll just switch off the buffer. You can see it follows the coastline. So it's a good first attempt. But what we want to do is the shallow waters of the estuary up here, we want to be nice and small meshes. This is much too high resolution along the sort of open boundary away from our area of interest, so we can reduce them. But what we're going to do is we're going to use the calculator function now. But the first thing we need to do is interpolate bathymetry data onto this mesh. And you should remember how to do that from day 2. You go to File, New, 2D Interpolator. Let's give this 2D interpolator a name, so double click on it, metadata. Let's call it Southampton Water Bathy, just so it stands out, we remember. And what we can do is the Southampton Waters bathymetry we brought in earlier, we can drag to that. Again, just make sure that in the data it's the Z that's selected. Okay. So let's select our mesh, go Tools, Map Object, and choose this Bathy object here. Again, because this file is quite big, it will take a bit of time. But what we're going to do is, this is the important thing as well, remember Telemac's looking for bottom, units are meters. We didn't change any of the properties, so it's using the inverse distance interpolation method. There's other methods built in, and depending on how your Bathy data is, you might want to use a different method. But let's just wait now until that finishes. The bigger your number of nodes, the longer it's going to take, and the bigger your data set is as well. My computer's running a bit slow today for some reason. It should take a little bit faster than this, but we'll just be patient. When you've got an extremely dense mesh, like the mesh I generated for Australia, which I'll show you in one of the lectures, and this actually took almost 3 or 4 days to just interpolate onto the mesh. I had so many grid nodes. So again, the faster your computer, the better. Okay, so we're done. When we click OK, now you can see we've got each of the nodes has bathymetry interpolated onto it. So what we're going to do now is create another mesh, but this time we're going to use this mesh to kind of refine it. And what we want is, in the area here that's deep, we want big grid cells, in the order of sort of 2,000 meter triangles. Where it's small, we want our grid cells to be, say, 150 meters. So what we can use is the calculator. And what we can do is click on the mesh, go Tools, Calculator, or select the calculator icon here. And what we're going to use is a a special expression which I go through in detail in the notes, but essentially it takes the depth and it converts it into a triangle size. So for A, we are going to use the value 11.96. For B, we're going to use the value of 122.52, and then for C, we're actually going to select the mesh. We just need those three parameters. So our expression is going to be A times the absolute of C, so if it's positive or negative, to the power of 1.2 plus B. In terms of the name, let's call this mesh D brackets Z. So it's sort of rate of change of depth, and we'll give that unit. So let's just check. A is 11.96, B is 122.52, and this is the mesh. And then we can evaluate. And it's normally done quite quickly. So what we'll do is create a new 2D view and drag the mesh into there. And what you should see now is if we double click, go to color scale, show legend. I'm just going to make the min 120, make the intervals 250. Let's just try that. What you can see is we're going to have small triangular sizes, 120 where it's shallow, more like so 230, 250 where it's big. Okay, now what we can do now is use this new mesh and bring it into the density of our area. However, we're not going to use all of the mesh. We're not going to use all of the mesh, we're just going to use a subset of that mesh to define the density. So we're just going to use this kind of upper area up here. So if we click on open, if you select this mesh DZ boundary file, and if you just drag that in, we're just going to use the mesh within this sort of area here, where we've got nice high resolution data. So if you click on your mesh, go Tools, T3 Mesh, Extract Subset, select that as your boundary file. It should be down near the bottom, and click OK. And there's our subset. We can just drag that into a new 2D view, and you can see that it's just a subset of the mesh. So we're going to use that for our density. Now what we can do now is create a the final thing actually before we create our mesh is, again, within a certain area near the coast, we want our density to be a certain size, a minimum size. So I'm going to load in this density 600, and I'll just drag that again to the 2D view. I'll switch off the boundary one. So within this coastal area, and actually how I created this is a 20-meter isotherm. To do that, you can click on a mesh, go Tools, Extract Isoline, Single Isoline, and you can select 20 meters, and then just join it up around. So within that area, I want the minimum grid size to be 600 meters. So we're actually going to use 300 different things, three different things to influence this. So you can see that the value of this line is 600. Okay, so what we're going to do is create a new mesh generator, File, New Mesh Generator. Let's call this one Southampton Water Reel 2. Let's set the default length as 200 meters. Click OK. And what we want to do now is just drag all the same things in from our last mesh. So the outline, I'm just going to drag the outline in. The density will be buffer 600. As well as that, I'm going to drag the mesh in, just the subset. we want to drag in 600 as well, so make sure density 600 is in there. For the hard lines, we're going to do the two resampled, Isle of Wight and Poole Harbour. So you should have the outline, 200 buffer, the mesh, the density 600 and the resample. So let's click on that and let's run that. Again, it might take a while, just my computer's being a bit slow. This will take even longer just because we're going to create more grid cells now. Again, we just have to be patient. This really is taking a while, isn't it? Again, you know, if you create a very big grid, this could take a long time. Okay, it looks like it's almost there. Okay, that's done. So click OK. Now let's have a look at this new mesh. So let's create a new 2D view. What I'm going to do is let's name this mesh straight away. It's always good to get into the habit of naming things. It just makes it easier to follow. Let's call this Southampton Real Mesh 2. Okay. Look at that in the 2D view, and what you can see now is that the mesh nicely goes from low resolution to sort of higher resolution. And even if you look in the channel, it's lower resolution in the deeper water, higher resolution, for example, here in Bramble Banks. This is a much nicer mesh. And we've got about 18,000 grid points. 18,000 grid points there. 34,000 elements. So let's click OK. Now what we need to do is, like before, we need to map the symmetry onto this mesh. So if you go Tool, Map Object, and let's use the Southampton Water Bathy we created earlier. Again, it's important to call this bottom, units meters, click OK. Again, this will take a while just because our grid is so much bigger now. Once this mesh is created, once the bathy is interpolated onto the mesh, we can create a new cellophane object, and that's essentially what we need to fix this. So you can see we've gone through various steps, but to really make a proper mesh and to do it really well, it can, as I said before, take several weeks. We've sort of done the hard work for you to find the land boundary, but sometimes even just creating the appropriate land boundary can take several days. Okay, that's finished, so we can click OK, and what you can see now is we've got the mesh onto that. So we go File, New, Cellophane Object, and let's drag this mesh onto that. Now, in terms of the cellophane object, let's call it Southampton. Let's call it SW Real. Okay. With the new mesh, remember to name it bottom under the cellophane object there. Click on Southwest Real, save, and save that to day 3. Again, it's good practice to get into the habit of saving your workspace as well. Now what I'm going to do is jump forward a few steps before I sort of run Pixis. We're actually going to create a second mesh as well, and we're going to use this on day 5. But to create this mesh, what I want to do is raise the level within Bramble bramble bank here.